So the next concept in determinants is minor and cofactor of an element. So first we will understand the definition of minor of an element. So minor of an element Aij is the determinant obtained by deleting the ith row and the jth column in which Aij lies. So we are obtaining the minor by deleting the ith row and the jth column in which the element is belonging. So note 1, minor of an element Aij is denoted by Mij, capital Mij. Note 2, minor of an element of a determinant of order n when n is greater than equal to 2 is determinant of order n minus 1. So we will consider an example to find the minor of elements 6, 8, 2, 4 in the determinant 1, 2, 3, 4, 5, 6, 7, 8, 9. So solution. So since 6 lies in the second row and the third column, its minor is M23. So we are deleting the second row and the third column to obtain the minor of 6. So the 2 cross 2 determinant we obtained is 1, 2, 7, 8. So on simplifying, 8 minus 14, which is equal to minus 6. So minus 6 is the minor of the element M23. Next, 8. So 8 lies in the third row second column. So we have M32, and M32 will be equal to the determinant which is obtained by deleting third row and the second column. So we get 1, 4, 3, 6. So 6 minus 12, which will be equal to minus 6. So the minor of M32 is minus 6. Now similarly we will calculate the minor of 2. So 2 lies in the first row and the second column. So M12 is equal to 4, 6, 7, 9. So on simplifying, now we get 36 minus 42, which is equal to minus 6. Next, similarly we will calculate the minor of 4, which lies in the second row first column. So on simplifying we get 18 minus 24, which is equal to minus 6. So we have obtained the minor of all the 4 elements. Next, cofactor of an element. So cofactor of an element Aij is denoted by capital Aij and is defined by Aij is equal to minus 1 raised to I plus j into Mij, where Mij is the minor of the given element. Next, we will understand it using an example. So consider a 2 cross 2 determinant. So a 2 cross 2 determinant has 4 elements, A11, A12, A21 and A22. So cofactor of A11, that is capital A11, which is equal to minus 1 raised to 1 plus 1 M11. Similarly, so the minor in a 2 cross 2 is obtained by deleting the first row and first column. So minor of A11 is A22. So we get minus 1 raised to 2 into A22. So minus 1 is raised to even power. So it will be positive. So A22 is the minor, is the cofactor of the first element. Next, similarly, cofactor of A21 will be equal to capital A21, which is equal to minus 1 raised to 2 plus 1 M21. So minor of A21 is A12. So minus 1 raised to 3 A12. minus 1 raised to 3 we get a negative sign. So minus A12 will be the cofactor of A21. Similarly, for a 3 cross 3 determinant now, the cofactors are calculated as follows. So in simple, while finding the cofactors, the minors are always associated with these signs. So each element has a particular sign based on minus 1 raised to I plus j. So the sign notations are plus minus plus, minus plus minus, and plus minus plus. So we will consider an example now. Find minors and cofactors of all the elements of the determinant 1, minus 2, 4, 3. So minor of the element Aij is denoted by Mij. So first we will calculate the minor of the first element, which is obtained by deleting the first row and the first column, which is equal to 3. Next, minor of first row second element, which is obtained by deleting the first row and the second column, which is equal to 4. Similarly, minor of A21 will be obtained by deleting the second row and the first column, which is equal to minus 2, and minor of A22, which is obtained by deleting the second row second column, which is equal to 1. Now, by making use of the minors, we will calculate the cofactors. So cofactor of an element Aij is Aij equal to minus 1 raised to Aij into Mij. So A11 will be minus 1 raised to 1 plus 1 M11. M11 value we have already obtained, it is 3. So on simplifying we get the cofactor as plus 3. Next, A12 will be minus 1 raised to 1 plus 2 M12, and M12 is equal to 4. So on simplifying we get minus 4. Next, A21 will be equal to minus 1 raised to 2 plus 1 M21, which is equal to minus 1 raised to 3 into minus 2. So we get plus 2. Next, A22 is minus 1 raised to 2 plus 2 M22, which is equal to minus 1 raised to 4 into 1. So on simplifying we get plus 1. So we have obtained the minors and cofactors of the given matrix, 2 cross 2 matrix. Next, find the minors and cofactors of the elements A11, A21 in the determinant and delta equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. So by definition of minors and cofactors, we have minor of the first element, that is first row first element, will be equal to M11, and it is obtained by deleting the first row first column. So the 2 cross 2 determinant obtained is A22, A23, A32, A33. On simplifying we get A22, A33 minus A23, A32. Next, the minor of A. So first we will calculate the cofactor of A11. So A11 is equal to minus 1 raised to 1 plus 1 M11. So already we have calculated the minor, just multiply it with minus 1 raised to 1 plus 1, which is plus 1. So we get the cofactor as A22, A33 minus A23, A32. Next, the cofactor, the minor of the second row first element, which is obtained by deleting the second row and the first column, is equal to A12, A13, A32, A33. So on simplifying we get A12, A33 minus A13, A32. So the cofactor of A21 will be equal to minus 1 raised to 2 plus 1 into M21. So minus 1 raised to 2 plus 1 we get a negative sign. So minus 1 into the minor M21, On simplifying, we get minus A12 A33 plus A13 A32. Next, write the minor and cofactors of the elements of the following determinants. So the first question is 2 minus 4 0 3. So minor of A11 will be equal to 3. Next, minor of A12 is equal to 0. Minor of A21 will be equal to minus 4, and minor of A22 is equal to 2. So using the minors, we can calculate the cofactors. So A11 will be equal to minus 1 raised to 1 plus 1 M11. So 1 into 3, we get 3. Next, A12 will be minus 1 raised to 1 plus 2 M12. So we get minus 1 into 0, which is equal to 0. Next, A21 will be minus 1 raised to 2 plus 1 M21, and M21 is minus 4. Minus 4 into minus 1, we get plus 4. Next, A22 will be equal to minus 1 raised to 2 plus 2 M22, which is equal to 1 into 2, which equals 2. Next question, write minors and cofactors of the elements of the following determinant. So we will consider a 3 cross 3 matrix. So 1 0 0 0 1 0 and 0 0 1. So minor of element of first row are minor of A11, that is M11, equal to the determinant 1 0 0 1. So we get 1. And similarly, minor of A12 will be equal to M12, which is obtained by deleting the first row and the second column. So the determinant is 0 0 0 1. So 0 minus 0 is equal to 0. Next, minor of the first row third element, which is equal to determinant 0 1 0 0, which is equal to 0. Next, minors of element of second row are minor of A21 is M21, which is obtained by deleting the second row first column. So we get 0 minus 0, which is equal to 0. Similarly, minor of A22, which is equal to M22, is obtained by deleting the second row second column. So we get 1 minus 0 equal to 1. Next, minor of A23, which is equal to M23, is obtained by deleting the second row and the third column. So we get 1 0 0 0. On simplifying, 0 minus 0 is equal to 0. Next, minor of element of third row are minor of A31, which is M31. So it is obtained by deleting the third row and the first column. We get 0 0 1 0. So 0 minus 0 is 0. Minor of A32 is equal to M32, which is obtained by deleting the third row and the second column. So on simplifying, we get 0. Minor of A33, M33 is equal to 1 0 0 1, which is 1 minus 0 equal to 1. Next, we will calculate the cofactors of the first row. So A11 equal to minus 1 raised to 1 plus 1 into M11. So M11 we have already obtained as 1. So 1 into 1 we get plus 1. Next, A12 will be minus 1 raised to 1 plus 2 M12. So minus 1 raised to 1 plus 2 will be minus 1, and minus 1 into the minor M12, that is 0, is equal to 0. Next, A13 will be equal to minus 1 raised to 1 plus 3 M13, which is equal to 1 into 0, that is 0. Cofactors of the elements of second row. A21 is equal to minus 1 raised to 2 plus 1 M21, which is equal to minus 1 into 0, which equals 0. Next, A22, which is equal to minus 1 raised to 2 plus 2 M22, we get 1 into 1 equal to 1. A23 equal to minus 1 raised to 2 plus 3 m2 3. So minus 1 into 0 we get 0. So finally we calculate the cofactors of the third row a31, which is equal to minus 1 raised to 3 plus 1 m31. So 1 into 0 we get 0. Next a32, which is equal to minus 1 raised to 3 plus 2 m32. We get minus 1 into 0, which is equal to 0. Next finally a33 minus 1 raised to 3 plus 3 m33, which is equal to 1 into 1, which equals 1. So we have calculated the minors and cofactors of a 3 cross 3 matrix. Next, result 1. So sum of the product of elements of any row with their corresponding cofactor is always determinant of the given matrix. Next, so we will consider the proof for this. So expanding the determinant along R1, we get a11 into minus 1 raised to 1 plus 1, a22, a23, a32, a33, which is the cofactor of the first element. So we are multiplying the first element with the cofactor with its cofactor. Similarly, second element into its cofactor, and third element into its cofactor. Now on simplifying, we get a11 into a11 plus a12 into a12 and a13 into capital A13. So delta is equal to sum of the product of element and its cofactor. So similarly, delta can be calculated by other 5 ways of expanding. That is, we can make use of R2 and its cofactor, R3 and its cofactor, or we can make use of all the 3 columns with their cofactors to calculate the value of the determinant. Next, note result 2. The sum of the product of elements of a row with corresponding cofactors of any other row is 0. So here we are considering the elements of R1 and cofactors of R2, or elements of C1 and cofactors of C3. So there is change in the elements and their cofactors. So we are considering the elements of first row and the cofactors of the elements of second row. So on simplifying, we get a11 into cofactor of second row first element, a12 into cofactor of second row second element, a13 into cofactor of second row third element. We get minus a11 a12 a33 plus a11 a32 a33 plus a12 a11 a33 minus a12 a13 a31 minus a13 a11 a32 plus a13 a31 and a12. So we can simplify it. On simplifying, we get the value as 0. So the result 2, it states that when we are considering the sum of the product of elements of a row with the corresponding cofactors of some other row, then always the value will be equal to 0. So first question, using the cofactors of elements of second row, evaluate the value of the determinant. Delta is equal to 538,201,13,123. So here we are using the property 1, or the result 1 we studied earlier. So a12 cofactor of 2 will be equal to minus 1 raised to 2 plus 1, 3 into 3, which is 9, minus 16. So we get plus 7. Similarly, the cofactor of second row second element A22 is equal to minus 1 raised to 2 plus 2, 5, 8, 1, 3. So on simplifying we get 15 minus 8 which equals 7. Next, cofactor of the second row third element which equals minus 1 raised to 2 plus 3 into 5, 3, 1, 2. On simplifying we get minus of 10 minus 3 which is equal to minus 7. So we have calculated the cofactors. Now we will calculate the value of the given determinant by using the result delta of A, that is determinant of A is equal to A21 plus A22 cofactor of A22 plus A23 and into cofactor of A23. So on simplifying we get 14 plus 0 minus 7 which is equal to 7. So here we are calculating the value of the determinant by making use of cofactors. Next question. Using the cofactors of the elements of third column, evaluate delta equal to 1xyz, 1yzx, 1zxy. So first we will calculate the cofactors of elements of third column. So A13 is equal to minus 1 raised to 1 plus 3, 1y and 1z. So on simplifying we get z minus y. Similarly A23 will be equal to cofactor of the second row third element minus 1 raised to 2 plus 3 which is 1x 1z. So on simplifying we get minus of z minus x. Next A33 will be equal to cofactor of xy, that is minus 1 raised to 3 plus 3 which equals 1x 1y. On simplifying we get y minus x. So apply the result, that is multiply the elements of the third column with its cofactors. So on simplifying we get yz into z minus y minus zx into z minus x plus xy into y minus x. So on simplifying we get y into z square minus y square z minus z square x plus x square z plus xy square minus x square y. So this is the value